Okay, we're back again. We are going to look at the pentagon. The pentagon. I wonder if I can do it on here. Probably got enough room. All right, I want black. Everyone's favorite. Black. Oakley dokley. All right, so pentagon, 5 diagonals. How many diagonals has a 15-sided polygon? Wouldn't it be nice if we had a formula for that? Well, I think we do. What is it from memory? I think it's this. N minus 3 on 2, I think. But that's not going to cut it because we're in a chapter on combinations. So unfortunately, they're not going to let me get away with that. And I now need to erase that. So let's erase it. Back to pen. All right. Thinking of combinations. Now, if you haven't done this question and you're watching, then try and do the question first. Don't just watch the answer. Try and do it for 5 minutes. Although this question really isn't that hard, it's just you just need to know how to think about it. Because what are you doing if you choose a diagonal? If you draw a diagonal? A diagonal, what is it? We're connecting or choosing 2 vertices to connect out of, well, in this case, out of 5. There'll always be 2 that we're choosing. Like, let's say we choose that one and that one, right? There's 5 vertices. I want to know how many different ones can I choose, and then I join them up. And the order doesn't matter. So maybe that's A, and I'm choosing A, B, and C, and I've chosen AC. Well, the formula is going to account for the fact that I could choose CA, right? So that, the formula's not going to worry about the CA once you've chosen the AC. Order doesn't matter. We know how the formula divides by r factorial, and so order won't matter. So n choose 2. That's, that chooses all the diagonals, doesn't it? In our example, it would be 5 choose 2. But if you put that into the calculator, you're going to get 10. And clearly there's only 5 diagonals. And the problem is, if you choose that side, that side, that side, that side, they're not going to make diagonals, are they? So if I was to choose the AB combination, which also includes the BA, it's not a diagonal, right? Or if I chose the BC, it's not a diagonal, it's an outer line, or the CD. So how many ways are there to make those choices between vertices that I don't want? Well, there's 5 of them, same as the number of sides, or same as the number of vertices. So I'd have to minus 5 to get the diagonals. Or with my more generalized formula here, I could n choose 2 minus n, right, where n is the number of vertices. Okay. So all of this is leading me to think that the 15-sided polygon, should be 15 choose 2 minus 15. So let's go to the calculator and find out what that is. 15 choose 2 minus 15. And I need to delete all of this stuff first. Change back to a cursor, go to your calculator, we want 15, we want to choose 2, because we're choosing 2 vertices. All the different ways you can choose 2 vertices, but then some of those ways make the outer lines on the shape, so we've got to minus away those 15. And we get 90 diagonals for a 15-sided polygon. If you don't believe this works, what about a square? How many diagonals do you get on a square? You only get 2, 4. So you can check the formula on some simpler shapes. 4, choose 2, minus 4. There's your 2 diagonals that you get on a square. You could try a hexagon. I think you get 9 diagonals on a hexagon from memory, but you could draw the picture and just make sure that the formula does indeed work. But logically it should. So that's a pretty cool question, something a bit different application there. Okay, I will come back on the next video and we'll do question 16.